So today's topic is text visualization. So in this slide, I want all of you to remember two terms. One is what is this corpus and what is corpora. All right. So this corpus and corpora are the terms, okay, that has been used in exclusively in data visualization related to text. Okay. So corpus is nothing but collection of documents. Okay. So corpora means the plural for corpus is corpora. Okay. So please remember these two terms. So corpus is to define a collection of documents. And then the plural form of corpus is corpora. So these two terms are often, or this will be exclusively used in terms of visualization. Right. Now, if we are talking about corpus or corpora, okay, so these objects can be collection of words, sentences, paragraphs, documents, sometimes collection of documents. Okay, so it is starting from the basic. Okay, sometimes we may even consider images and videos, right? For example, documents have a format and often include metadata, that is about the document, data about the data. All right. For instance, if I am having certain document file, right? So inside that I have some document, okay, some document file. But in addition to that, I have a metadata that is about that particular document. That means who is the author, when the document has been created, maybe the size of the document, sometimes the comments that has been given, right? So these are all the metadata about the document that has been created. Now, this information retrieval systems are used to query corpora. That means which requires computing the relevance of a document with respect to a query. Now, if I want to retrieve certain information from a document, right? Now, based on visualization, that too based on text-based visualization. Now, this information retrieval system will be, more relevant, right, with respect to the query that we make to a corpus or to a corpora, right? Now we can even compute the statistics about the documents. That means the number of words or the paragraphs or the word distribution or the frequency of the words that has been repeated throughout the document. And then all these can be used for author authenticity, right? Then we can also identify relationships between paragraphs or documents within a corpus, right? So, when we in our lab sessions, when we have displayed this text-based visualization in a word cloud, I said that word cloud is showing us, the report of a particular document. Report in the sense how often a particular term or a particular word that has been repeated. Okay, so that will be projected in a larger font size, right? Comparatively, the other words, right? So now this is actually giving us a report of that particular document. That means, so this, after seeing a word cloud, our user can understand what that document is all about. Okay, what does the document says, right? So it is again to identify the relationships between the paragraphs or the documents within a corpus. Now, there are three levels of text representations. One is lexical level, then comes the syntactic level, and then the semantic level. Okay. So again, previously when we discussed about text-based visualization, we have seen about a term called as token, and then the table, token table, right? So everything is coming under these levels of text representation, coming under each and every level, right? So firstly about lexical level. So this lexical level, it is the initial level, okay? When we are about to visualize a text. Now, this lexical level is concerned with transforming a string of characters into a sequence of tokens. Okay. So whatever string that has been given in a document, so that will be transformed into tokens. Okay. Then this lexical analyzers, they process the sequence of characters with a given set of rules into a sequence of tokens. So that is used for further analysis. Now, tokens can include characters, words, phrases, lexemes, and all other associated attributes. So this is the first level. Then the second level is the syntactic level, right? The syntactic level, it actually deals with identifying and tagging each token's function, right? Now, if we have given any string, okay, and that string has been converted to a token, right? Now that token should give some additional information. That means it should have certain attributes, okay? Or we are tagging with some function of that particular token, right? It could include a date, it could include a place, person, organization, or even time. Okay, so this is the next level. That means we are giving some more additional information about the tokens that has been identified. Then the third level, which is your semantic level. Actually, the semantic level is in this level only the exact meaning and the relationships between the pieces. Okay, so that has been extracted. Okay, so when we are converting or when we are about to visualize a text, right? So initially, all text, the strings, characters are converted to a token, and then secondly, we are tagging the tokens function, and thirdly, we are extracting the meaning and the relationship, right? Now, it is to define an analytic interpretation of the full text within a specific context or even independent of context, right? So there are three levels: lexical level, syntactic level, and semantic level of text representation. Then comes the vector space model. Okay, so in our lab session, we have seen about this count vectorizer. So count vectorizer is actually used to to find the frequency of the words that has been taken place in a particular document, right? So for that count vectorizer, there is a vector space model. So initially, the first step is to remove the stop words. Okay, that is what you can see. A term vector is a vector in which each dimension represents the weight of a given word in that document. Then to calculate, firstly, we have to clean up the stop words. Okay, like okay, so these are all the stop words. Okay, so they are removed. Okay, and the words that share a word stem are aggregated together. Okay, so the main set of words. Okay, so that will be taken into account. Right. So I have given a pseudocode for calculating the frequency or calculating the count. Okay, count of the words. Okay, and also to remove the stop words. Okay. Then how do we compute a weight? Okay, weight for a document, right? Now there is a concept called as this TF-IDF, which is term frequency inverse document frequency. Now this is again to find the number of words that has been frequently frequently repeated. Okay. Now the term frequency or the number of times that word occurred in the document. Okay, so here there is a calculation for this TF-IDF. So let n be the number of documents. So we have document frequency of a word for the number of documents that contain that word. Okay, so here let n be the number of documents. So we define TF-IDF of a word, which is equal to term frequency of that word into logarithm of number of documents divided by the document frequency of that particular word. Okay, so how effectively or how often a particular word that has been that has been repeated. Okay, so the best example here is when we Google it, right? When we Google anything, not only in Googling, when we are searching for anything in any search engine, as soon as we start typing a letter, okay, for instance, if I want to search for text visualization, now if I start typing the letter T, okay, immediately, we recognize a drop down, the list of suggestions, okay, what the user is, about to type, okay. As soon as I start typing TEX, then as soon, immediately the machine understands that the user is about to type text. All right. So this particular application is done through this TF-IDF. Okay. So there is a best example. Now there is one law called as the Zipf's law. Okay. So here the Zipf's law, actually the person here is George Kingsley Zipf. Actually, he is a linguist. Linguist means he is master in languages. Okay, so he stated the distribution of words in natural language corpora using a discrete power law distribution. So Zipf's law states that in a typical natural language document, the frequency of any word is inversely proportional to its rank in the frequency table. Okay, so this is the law stated by Zipf. Okay, he is a Harvard linguist, namely George Kingsley Zipf. Okay, fine. Now, when we are talking about text-based visualization, there are two types of visualization. One is single document visualization, and the other one is document collection visualization. Okay, so there are two types of text-based visualization. One is single document visualization, and the other one is document collection visualization. Right. Here you can see, which is familiar to all of us, which is a word cloud. Now the font size and the darkness are proportional to the frequency of the word in the document. Okay, you can see that we have already experienced this. We have experimented in our lab, right? Now, this word cloud is an application coming under the single document visualization, right? Word cloud is also known as text cloud, okay, or which are the layouts of raw tokens colored and sized by their frequency within a single document, right? We have an open source tool called as this Wordle.net. Okay, so this is again using this we can have a word cloud. Okay, so Wordle representation is generated by the free service, which is a Wordle.net. So this is what your word cloud. Okay. Now, next one is about word tree. The first one is about word cloud, coming under single document visualization, and the second, second type coming under single document visualization is word tree. Okay, that means our document can be visualized in these types. One form is word cloud. The second form is word tree. Now, word tree is again a visual representation of both term frequencies as well as their context. Now, here the root of the tree is a user specified word, and the branches represent the various contexts in which the word is used in the document. Now, I will show you this. Right. Now, here you can see the user specified word is the. Okay. Actually, it is a stop word, but still, for just for our understanding, we have taken. Right. Now, word tree, it is again, we have a root word and how the branches are developed from that root word. Okay, so the branches of the tree represent the various contexts following a root word or phrase in the document, right? So this is the second form of, a single document visualization, which is word tree. First one is word cloud. Second one is word tree. And third one is, we have another form of visualization called as text arc. Okay. Now, text arc is nothing but, here we have like a elliptical shape, elliptical shape, right? Like a circular shape, right? So visualization will be in a circular shape, right? So on the center we have our again the root word, right? So around that particular word, how the word is being related in that document, okay? How it has been used in that particular document, okay? That is what your text arc. So text arc is a visual representation of how the terms relate to the lines of text in which they appear. Now, every word of the text is drawn in order around an ellipse of small lines, right? Words with higher frequencies are drawn within the ellipse, pulled by its occurrences on the circle, right? You can see in the thing, right? This is what your text arc. Now you can see the words that occur evenly throughout the document are positioned in the center of the display, right? You can see here the evenly distributed, okay, evenly, right, throughout the document are positioned in the center of the display, while the words that appear only in specific sections are located closer to the circumference. Now here, this is another form of text visualization, right? In coming under single document visualization. So firstly, word cloud. Secondly, it is word tree. Third is text arc, right? And the fourth one is simply arc diagrams, okay? So there is a difference between text arc and arc diagrams. Now, arc diagram is also another form of text-based visualization, again, displaying the repetition in a text or any sequence. Now, repeated sequences, subsequences are identified and connected by semicircular arcs. Okay. Now you can see there is an application where one Western composer, so he has composed the music, right? Based on that music sheet, right? So that is again considered as a document, right? So based on that sheet, how the repetition takes place, right? From one line to the other line, or maybe one phrase can be repeated, So based on that, a semicircle has been drawn. So you can see repeating sequences are connected with semicircular arcs. You can see many semicirculars. So all these semicirculars are the repeated sequences that has been connected as a semicircular arcs. Okay, now this is the fourth form of single document visualization. And the final one is literature fingerprinting. Okay, so this literature fingerprinting is nothing but, again, to visualize the features used to characterize the text. Okay, characterize the text. Now, when we are visualizing it, okay, we have to understand whether it is a single document or the collection of documents. Now, we will give you an example. Now, if I want to analyze one paper or one document, okay. Now, in that particular document, when we are applying this literature fingerprinting, now that paper, okay, that document will be transformed into a unique vector representation. We name it as a fingerprint. Okay. Now, if the fingerprints are highly similar, okay, then it indicates that they likely cover the related topics. All right. So actually, this literature fingerprinting is useful for to identify the patterns or the trends, okay, given in that particular document. And also, it has been used for various documents also, right? Now, when we are about to extract certain features, okay, now that allows the user to look inside the document and analyze the development of the values across the text, right? Now, these are the 5 forms of visualizing a single document visualization, right? Starting from word cloud, then comes word tree, then text arc, then arc diagram, and then literature fingerprinting. Now, this is single document visualization. Now, the second form of, or the second type of text-based visualization is document collection visualization. That means here is the case where you have a collection of documents, and how do we visualize that, or how the collection of documents can be taken into account to visualize, to understand what are those collection of documents. Now, the goal of the document collection visualization is to place the similar documents close to each other and dissimilar ones far apart. Now, here, the basic clustering based concepts, they come into account here. Okay. Now, as I said, the common approaches are the graph spring layouts. We can use clustering like k-means, hierarchical expectation, maximization, support vector, and self-organizing maps, right? So we have this the document collection visualization using self-organizing maps, then using themescapes, right? So firstly, using the self-organizing maps. Right, coming to the self-organizing map is actually, it is a machine learning algorithm, which is an unsupervised machine learning algorithm. All right. So this is to actually to visualize and analyze high dimensional data. All right. So it helps to represent and organize large amounts of unstructured textual data. Okay. That is why we are talking about collection of documents, right? So firstly, in the context of document collection, our SOM, okay, self-organizing map algorithm, it will firstly cluster the similar documents. That means it by training the SOM on a document collection, it groups the similar documents together. Okay, that will allow us to visualize the structure of the data set, right? So firstly, it will cluster the similar documents and then to identify the patterns. Now, SOM, again, it helps us to uncover the hidden patterns and the relationships between the documents, right? And then it will go for dimension reduction. Okay, so earlier I told you about to analyze high dimensional data. It is very challenging to visualize high dimensional data. So some of the solutions are to reduce the dimension so that we can able to visualize the same. So again, SOM, it reduces the high dimensional data, like the term frequency or count vectorization. Okay, using all this, it reduces the high dimensional data to a 2D map. Okay, so making it easier to analyze and visualize, right? The second way of document correction visualization is themescapes. Themescapes is nothing but it will look like a mountain, mountain-based visualization. Okay. Now you can see in the second point, the taller mountains, it represents the frequent themes in the document corpus. That is, height is proportional to the number of documents relating to the theme. All right. So this is something like a mountain-based visualization, right? So that is what your themescapes. And then finally, you have document cards, right? So document cards is again something which is we can relate with literature fingerprinting in single document visualization. Now, document cards is nothing but when we are having a large collection of documents. Now we can extract certain topics from the document cards, right? In our lab session, you would have done one topic called as this topic modeling or topic labeling. Okay, so hidden topics can be created, right? Likewise, in the collection of documents, we can have or we can extract the we can extract the basic or the fundamental or the root of the particular documents. All right, that is what your document cards. But in detail, if I speak about this document cards, you can see what is this. Again, it is used to content. It is used to organize our collection of documents. It is used to display the summarized information. All right, and then we can extract the topics or the root topics given in the particular document, right? Maybe many other information can be extracted, and then metadata, that means data about the document, okay, like date of creation, the author, the file size, okay, everything can be extracted. Based on that, we are creating a visualization, right? And then we can have like viewing a document or modifying it, right? Then we can have something like some interactive visualization also that could take place, right? So now based on text-based visualization, we are classifying that into single document visualization and then document collection visualization. That means collection of documents. When we are having like 100 documents, how are we going to visualize that? Right. So for that, we have certain forms. Now, when it is single document visualization, there are like 5 different forms. And when it is document collection visualization, there are 3 different forms, right? So this is all about text-based visualization, but there are certain other extended text visualization, namely software visualization. We have search result visualization, and then temporal document collection visualization, then representing relationships, right? So these are all some of the extended text visualization. I strongly suggest all of you to have a note on all these 4 types and to explore what does it really, okay, what does it really mean. So I strongly suggest all of you to take a note of these 4 points. So with this, our text-based visualization is over and our module 4 is completed.